So you should be taking notes now on the bottom of page 1-1. The ionic bond is a bond between a metal and a non-metal. We're right here, Troy. Please pick up your pen. Troy, please pick up your pen and start writing.
Oh, I already got my pen up.
Thank you. Great, excellent. I see everybody on task. Ionic bond is a form between a metal and a non-metal. And very importantly, it is a transfer between electrons. The covalent bond, on the other hand, perfect note-taking, SJU. I'm going to go ahead and give a point for SJU for doing awesome on the filling in the notes on the ionic bond. The covalent bond, folks, however, is sharing of a bond. So I'd like you to take a look up here when you're done with this slide so I can show you an example. So if you're finished, I should see your eyes up here on this board. Here is the chemical sodium, right? Everybody remembers sodium? Raise your hand if you can remind me how many valence electrons sodium has. How many valence electrons sodium has? Yes? One. Good. I'm going to tell you that it bonds with chlorine, and that chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. This is going to form an ionic bond, okay? The way that you will draw this on your benchmark is you will draw this, and you will draw this cool little squiggly line that just says that the sodium is transferring its electron to the chlorine.
How do you remember all that on the benchmark?
All I'm reminding you of is in a covalent bond, which we know is an ionic because it's a metal and a non-metal, right? We know that. Metal, non-metal. And we know the most important thing, Troy, great question, the only thing I want you to remember on an ionic bond is the word transfer, okay? Transfer. Notice the transfer. On a covalent bond, guys, I'm going to show you now a covalent bond. Taking a look at fluorine. Thank you, everybody, for maintaining silence. Fluorine has 7 electrons, and if it bonded with one other fluorine, how many do they want to have to be happy? You can shout out. To be happy, how many does everybody? 8, exactly. So take a look, each one of these has 7, and so they will share. So also important for me on your benchmark, the second word I care about is share for covalent, okay? Ladies, thank you. Covalent. Perfect. Let's move to the next slide, and you should be on page 1-2 now. This is also a review of our first period, okay? This is a review of our first grading period, properties. You all should be writing down what the properties are. It's something that you can see and observe, okay? Here are 5 properties. Color. Troy, keep writing. Color. Melting point. Solubility, right? So right here on this one we're writing the 5 characteristics that can be observed that are properties. Okay? See, everybody's on task. Everybody's writing some examples of properties that can be observed. If you're finished, you should maintain silence, and if you're not, you should be still writing silently.
It's Monday. You got to do all these notes.
Troy, thank you. Please raise your hand if you still need more time. Okay, who said that? I did. You do need more time? Okay. If you're finished, guys, try and remember back to when we learned about these properties and what it is that was important about properties and how you distinguish compounds from one another. Good to go? Okay.
Go ahead.
So the first thing we're going to learn about, ladies and gentlemen, today is melting point. And I'm going to remind you what the definition of a melting point is. So you should be writing down the melting point is when you change from a solid to a liquid. Okay? I've got almost everybody writing. Great. I'm waiting for one more person to write. Great. Melting point. Changing from a solid to a liquid. This is where it gets important for our class. We already knew what a melting point was, right? Now we know that the higher the melting point, the more energy it takes to break something. So if I have to turn something up really high, that means that there's required to break that bond, okay? So if I have a bond, if I am holding hands with an atom, and it has to be turned up really hot for me to let go, that means it's a lot of energy that's required, okay? Please raise your hand if you need more time on this slide. The next slide is going to tell you about the difference in melting points between ionic and covalent bonds. So in an ionic bond, there are typically very high melting points, okay? Very high melting points for ionic bonds. In contrast, covalent bonds have lower melting points. So if you finished writing, I'd like you to take a look at the first stop and think. So, which one will melt first? An ionic bond or a covalent bond? And while you're thinking, I'm going to show you what we're going to be doing as a demonstration today. One of these is going to be an ionic, and one of these is going to be a covalent. And you're going to decide which one's ionic and which one's a covalent based on their properties, folks. Okay? And so what I want to know as you stop and think is, which one would melt first, an ionic or a covalent? Think about it for a second, then I'm going to call on somebody. Okay? Which one would melt first, an ionic or a covalent? So you should be writing it on the stop and think. What do you think? Which one would melt first, an ionic or a covalent? Okay? And the second one says, therefore, which one has more energy? Which one has more energy? So I'd like to see at least 5 or 6 hands telling me which one will melt first, ionic or covalent. Please raise your hand and tell me if you know. Yep, I see a couple hands. If you know which one will melt first. I see another few hands. Great. Looking for a couple more. Kayla, which one will melt first, ionic or covalent? Which one will melt first? Has the lower melting point?
Oh, covalent.
Covalent, exactly. It's tricky to remember that. And Shania, therefore, which one takes more energy to break, the ionic or the covalent?
Ionic.
Exactly. The ionic takes more energy to break because of that. Perfect. So, because the melting point is lower for covalent, it will melt first. So y'all should be writing that down on your stop and think. I'm coming. Maintaining silence. You guys are doing great. Maintaining silence. Can you sit up for me, please? So ionic will be the one that has the strongest bond, right? And covalent will be the one that melts first. Ionic will be the strongest bond, and covalent will melt first. Okay? So that's the first property we're going to discover today in our lab. I'm going to do a mini lab for you. The second property we're going to talk about is solubility. Solubility. Please write down what the definition of solubility is on your notes. You should have a bullet that says property solubility, and right below that you're writing down what the definition is of solubility. I've got Kayla writing it down. Today's starting to write it down. I see a lot of folks in the beginning of writing down what the solubility is. If you finished, think about when we talked about solubility before, what the definition is. Perfect. Exactly, right there.
Miss, come
We're
here.
going to do that next, okay? That's the first slide.
Miss, come here.
If you have a question, please raise your hand silently and I will come and talk to you. Okay? Right here. Okay? We'll do that in a second. Alright, so can somebody, now I'm going to wait for silence again, guys. Let's bring it together here, and I want to make sure everybody's silent and on pace with me, okay? So you should have finished the bullet. I will wait. We should have finished the bullet that says property solubility. We are now moving to the bullet that says solubility, ionic or covalent. And here we're going to compare and contrast ionic bonds and covalent bonds. Ionic bonds are soluble in water. Don't distract her. She's doing a great job. You need to be taking notes as well. Okay? Okay, but we're on the next bullet. Right here. Okay, ionic bonds are soluble in water, which means they dissolve in water. Ionic bonds are soluble. Great, Brene. Great, Janelle. Got Justin taking great notes. Cindy's taking great notes on the ionic and covalent difference. The difference between ionic and covalent, however, is that covalent bonds cannot dissolve in water. Okay? They will not dissolve in water. And we'll see that when we do our experiment in just a second. So I'd like you to stop and think